In this video, we're going to look at differentiating the exponential function. So this is the formula for the derivative of the exponential function that appears on the methods formula sheet. And you can see that the derivative of an exponential function is an exponential function. I think a more useful version of the formula is this one, which is a chain rule version. So the exponential function raised to some other kind of function is the derivative of this function multiplied by e to the original function. The most common mistake made when finding the derivative of an exponential function is that people use the pattern for x to the power of n on the exponential function. The exponential function derivative is very, very easy, and it is different from x to the power of n. So let's look at how the derivative of the exponential is in fact an exponential. So we know that the gradient of the tangent, so here's a point on the exponential curve. I've put a point here with a tangent line to it, and this is the equation of the tangent here. This is the coordinates of the point, the x coordinate and the y coordinate of the point. And we know that the gradient of the tangent is equal to the derivative for the function at that particular x value. And so I'm going to drag this point across, and we're going to look at what's happening to the size of the gradient and the coordinates of the point. So let's make this thing work. So you can see as the point moves, the y value is matching exactly the gradient of the tangent point. Even though the tangent line is moving, the gradient is staying exactly the same. So let's just pause this for just 1 minute, if I can make that pause. And so what we've got is for every single x value, you end up with the gradient of the tangent matching the y value for that particular point. And so what that means is that the derivative graph will have for this x value here, the derivative graph will have exactly the same y value. For each x value, the derivative graph will have exactly the same y value, as the y value, that's a terrible drawing, as the y value for the original graph. So I'm just going to put it on the original graph itself. So those green dots represent the derivative graph drawn over the top. And so what you get over here is your derivative graph also being exactly the exponential function. I'll let that play a little bit more. So let's use the formula to find the derivative of some exponential expressions. So we've got e raised to a cubic, and so this function here is like a chain rule, and so we're going to find the derivative of this multiplied by e to the power of this. So the derivative of x cubed minus 4x is 3x squared minus 4, and then you multiply it by the outer function, which is e to your original function. Easy enough. The second question has got exponentials all over the place. So what we're going to do, we're going to split this numerator and denominator up into separate individual fractions, each over 2e to the 2x. And when we do that, this is what we get. And then we can do some cancelling down. You can see I'll cancel the 2's here, these two here. I'll cancel those down. The 3 and the 2 I can't cancel, and this becomes 1 over 2e to the 2x. So now we're going to use our index laws to simplify each of those expressions. So it is 4x minus 2x, x minus 2x here, and just minus 2x here. If we tidy up those powers, we're now looking to find the derivative of e to these particular powers. So e to the 2x, 3 over 2 e to the minus x, and a half e to the minus 2x. And so we're going to find the derivative of these exponential functions, it's the derivative of the power times by e to the whatever the power was. And so when we do that, this is what we get. So the derivative of 2x is 2, and the derivative of minus x is minus 1, so that comes out the front and turns that into a positive, which is why this plus is in yellow. And the derivative of minus 2x is minus 2, so you've got a half times minus 2 here. We're going to tidy this up a little bit more by writing our exponentials with positive powers. And then finally, we're going to multiply our fractions together and end up, with this.